So I'll start the recording here. Does anybody have any questions as we start out today?
Oh yeah, what have I missed for the past 3 weeks?
Well, unfortunately, you've missed a lot. Would anybody want to give them a synopsis?
I'll make sure I watch the videos from the emails, rewatch them, put some notes down, and add some footnotes.
That sounds good to me. Well, we talked about structs, which are kind of game objects. They're the data type that holds the data for our game objects. We've talked about kind of the main update loop in a game. So in this game engine, it's this method update and then the other method draw are the two components of the main game loop.
All right.
We've talked about arrays or slices and adding like our depth charges to a slice of depth charges and working with them and updating their position in the game. We've talked about structure composition, where we add one type of data to another data type that we've defined. So we have like this entity, which is used throughout the game so far to represent location and dimension, and then if that component is active or not. And we have talked about drawing things on the screen. And we've also talked about collecting game input. So things like this right here, we can check if keys are pressed, things like that. And then we have our game, which our animation is a little choppy. And I don't know why I didn't think about this while we were here last week, but I figured out why it was choppy. It has to do with this method. We didn't load all the images in that method. So if we load the other image, then it's a little bit better. Not quite as choppy. So the way this works is we also introduced a library that I wrote to kind of go along with this class. And is asset loader.load concurrent directory.
Sorry.
You're fine. Is what we call to load the assets off of, in this case, our virtual file system. And it's loading 4 because we've defined 4 frames of our animation. But if we had 7 frames of our animation, then we could load 7. If we put 7 right here, the program would crash because it wouldn't find any more images beyond 4 images.
That is a mildly bad thing.
Yep. So that's kind of where we're at. Last week we had talked about working on submarines, but I kind of feel like now would be a good time to introduce a slightly different concept. And not that it's a new programming concept, but it's more for managing the state of our game. And that's the fact, let's look up at our game struct right here. Our game struct has a ship, it has depth charges, it has the image that we're going to display. But then down the road, we're going to want to add submarines to the game, and we're going to want to add torpedoes to the games. And if we start adding all of those things on our game, it'll make it a little bit more challenging to show something like a start screen or to change some of the logic of our level to maybe make it progressively more challenging.
All that be is like some sort of basic like background image, then just like a simple start button or whatever?
Yes, yeah. So what I propose we do is we create a level struct this week, and then we can kind of move our ship and our depth charges and things into the level struct, and then we can put our logic in creating the complexity of the level inside of a level instead of keeping it inside of our game. How does everybody feel about that? Does that sound like a good enough path to go on?
Yeah.
Okay, So just a heads up, if you're following along, I did make 2 changes in the Git repo since last class. I updated the library, the version of the library, and I also added something to the assets or to this raw directory. I added this library.svg, but we can't really see. Oh, there it is. It's showing us right over there. So after my catastrophe of trying to draw in front of class, I've actually added an SVG that has a different battleship, some depth charges, 2 submarines, and then we've got some torpedoes that I've been working on over here, and then some explosions. So I've added those to the Git repo since last week. So if you are following along today, you might want to pull that down beforehand, but just so you know, we have some assets there that we can work with going forward. All right, so if we need to create a level struct, what do we do?
We usually put in some file. Is that what you're getting at, or?
Yep, let's create a new file. And we will call this level. Okay. All right, we're going to be working off of our ship and our game because the game and our ship are linked together. Remember how we had that method that we passed to create more depth charges? So I'm going to kind of leave both of them open for right now. So what are some things that our game is doing that we're going to want our level to do? Yep, we're going to want to draw an update. We'll keep the same function signature. We wouldn't necessarily have to if there was a reason not to, but I think in this case it makes sense to keep the same function signatures there. All right, so what do we keep in our game struct that we would want in a level? Our ship? Probably all of these things right here, wouldn't you think? I would think so. Okay. And now we have a bunch of broken things. But at least our IDE is telling us that. So right here, our request change method, that's the one that we passed into the ship when we created the ship, doesn't have access to the depth charges anymore. So to me, it would make sense to have this request charge method be defined on our level instead of our game now, because that's kind of why we're doing this. So each level will kind of have its own self-contained logic and self-contained environment. And so we'll have the depth charges that will be a part of the level instead of a part of the game. And then that way, once a level's cleared, we can generate a new level and then swap them out and keep on playing. All right, so we're calling an update on our ship, but we no longer have a ship instance, so we can actually pull these 2 sections of our game, and we can put them over here on our level. Oh, yeah, we gotta pull this over too. So when a depth charge is no longer active, we'll just update and remove it from our slice. And then we have our draw methods as well. I propose that we take this vector.field draw rect, which is giving us our background, and put it on the level. As if we wanted like a night level, we could have that draw a different color. And then we're going to want to draw our ship and our depth charges, and then our ocean image. I think our ocean image will probably want to have as a level as well, because then we can, as levels progress, we can change that, you know, for maybe a dark level or whatever. So we can put this over here. Okay, so we got that, and then we'll draw our ocean image. All right. And then our layout, that's part of the game engine. But we're here, and we've got a ship, and we've got our ocean image that we no longer have. So our ocean image is going to go on our level. So we'll create a constructor method here for a new level, and we can take this right here. And then, let's see. And we will set our ocean image onto our level that we create in our constructor. And we can create a level. So I've got a logic question for you. I've kind of gone through and done some heavy lifting for our migration to a level. If we were to create a ship, should the ship be created in the game, or should the ship be created in the level layer? Now, maybe there's not a right or a wrong, but I think there's a better option.
The level.
You think the level?
Well, it depends on if you're gonna have them pick like a new ship every level, or if you're gonna carry the ship through the level.
Yep. And so it kind of comes down to our gameplay. I would say create the ship at the game level. Because if we want to keep score and health and things like that on our ship, we can just have one ship that we can pass to the level and say, okay, level, here's the ship that you're going to be playing with. And then we can keep the same ship along for one round of the game. That's what I would recommend. Does that sound all right?
Yeah.
So that means we need to put a ship. We need to put a ship back on our game struct. So we'll create a ship. But now we have another problem. We have now moved this request charge over to our level rather than on our game. So now we're going to have to kind of handle what that's going to look like. Does anybody have any thoughts? Let's get to stretch your brain a little bit with some brain teasers, some little logic.
So do you want to move you want to track the charges within the level?
Mm-hmm.
One option.
Yeah.
So you move the request actually over into the level. I don't know if there's a way to also pass like a function. You could still keep it in the game, but pass it, no, maybe that would make sense. That one probably makes the most sense to me, is to have it at the level, but I think you had mentioned earlier you like having the game track it, so I'm not sure.
Yeah, so I am going to, the way that I think about this, again, there's a lot of ways to program something. We can, it's just a variable, right? The function is just a variable, so we can actually not set it when we create the ship. And then we don't have to pass it in here. And then here, when we create a new ship, we don't have to pass it that function anymore. But we want a way to communicate. We want a way to pass the ship to our level. So it seems to me that adding it as a parameter here, we can set the ship, and we create our level, and now we can just call update for level, and we can pass the method for the level. And now every time that the ship gets passed to a new level, that request charge will be called for the level. And that way we can have the ship that is long living, that will last as long as we can play the game, but we're also updating and setting things for the ship so it has its proper callbacks. Does that make sense? Questions? Is our game going to work? No, it's not yet. We haven't finished our refactor, have we? Okay. I'm going to recommend something else as well. I just don't know what to call it. So I think we want to pass, like for every iteration that we create a new level, we want to put like an index for what that level is. Maybe index is a good thing for it, because we can use that index as the game progresses to change our logic for how we want to lay it out. Again, this is maybe something just kind of how my mind thinks about the problem of increasing the complexity as the game goes on. Things like that. All right, so we've got our level. We've updated our ship so that it can call back into the level when it changes. Let's see. So if we're going to keep track of an index for the level, we probably ought to have it on our game as well, so that we can keep track of it inside of our game and pass it into the constructor every time we call a new level. And then we need a level for our game, and we can create a new level. Let's see, subgame.level. Going to be new level dot level index, and then we'll pass our ship in as well. And now all of the work that we've been doing for our updates inside of the game, we can now just pass to our level. I think if that has everything right, it looks like we've got an error somewhere. Oh yeah, we forgot to update this. so I think if we did that right, we'll be back able to play the game where we were before we did that. Oh, good. Boat still drives, our ship drives. We can drop depth charges. All right, does anybody have any questions about going through that exercise? So think of it down the road a little bit now. If we have like a welcome screen, we can check to see if our level is nil or not set. And if that's the case, then we can just show the welcome screen. And we can build out a welcome screen much like that update and draw method that we did for the level. And then our welcome screen can be shown, and it will run through on the welcome screen until you hit some button. And then we can call back into the game and say, okay, create a new level. And then away we go playing that way. Does everybody feel all right with that? Okay. Should we work on some submarines now? Okay, so we will call a new file. So I've got to tell this story. It's been on my mind as we've kind of been talking today because everybody's just a little quiet. I was in a college class. It was a Python and a Perl class. And it was in a room, I don't know, maybe from like the wall to the edge of the TV back to the back of the couches. Like it was that big. There was 8 of us that signed up for the class. And the teacher had us do whiteboard exercises the whole class time. And so he would ask us a question and we'd be standing there with the marker and you couldn't sit down until you wrote something. Hopefully he'd written it correctly. Oh, I sweat bullets in that class every day because it was just so stressful to be standing there at the whiteboard and being expected to write things up there. But I learned a lot. So, you know, take that for what you guys will. But it was a good experience for sure. All right, so we have a ship, we have a submarine, and we want to add a submarine to our game, to our level. I'm trying to figure out how we want to look at that. Do you guys want to just think through this and kind of program it from scratch, or do we want to pattern it after our ship? Because it's going to work much the same as our ship. You guys can't let the old guys do all the talking in class. Asa, do you want to look at the ship so we can pattern it after it since you weren't here for the ship being built?
Sure.
Okay, we'll do that. Okay. So we have this ship here. And it has an entity. You remember what our entity did? I talked about it briefly.
I don't specifically remember.
It stored our location and our dimensions in the game.
Oh yeah.
We'll add a speed.
So one other question I had, or one other approach is that we pull out another thing to do by composition and actually make a vessel, or I don't know what you want to call it, that since they both seem to be logically common, other than maybe depth charges go down, either go up.
Yeah. We could definitely do that. I have.
I mean, it's better for review. I was just curious what your, like, there was a reason you wouldn't want to do that, or thoughts on it.
No, I mean, I had considered it. I think it does kind of come down to preference because I think they would share speed in common. And then to some level, they might store animations or have animations in common. So that could very well be done. And maybe as we progress, we'll refactor into doing that. Okay, so we have a request charge method on our ship. How about we create a request torpedo method for our submarine? And we will start with just a sprite. Because really, I haven't thought through the animations of the submarines yet. I mean, we could have them go, and then we could have them hit the edge of the screen and have an animation that they turn. But I'm not a great artist person, so I don't know if I can get that animation figured out in my head for right now. So we'll work with a sprite for now. And that's an image. What are some methods that we need on this submarine?
Its ability to move.
Its ability to move. So what might that look like?
Are the submarines going to be computer or another player?
They'll be computer for now. That would be kind of interesting to have somebody else be the submarine. That would be kind of cool. Yep, so we'll need an update method. And what goes along with our update method? Yep, so I'll have an update and a draw. And then we'll need a way to create it. Do we want all of our submarines to have the same characteristics? Or are our submarines going to be different? Like, do we want one that can, I don't know if drive is the right word, but propel itself faster? Do we want one that can shoot faster? You think so? Yeah. So we're going to have to think at least down the road about creating, like some of the logic behind creating a submarine. Some things that I've seen is when you populate a level, depending on the difficulty of the level, they'll go back through and randomly select something out of the enemies and kind of upgrade it, if you will. Or we could just tell it what it needs to be when it's created. I don't know if one's better than the other, but let's say, we wanted this submarine to propel itself slower, and this one to propel itself faster. They would have a different image. So our upgrade process would have to know to upgrade the image as well as the stats about the submarine. I don't know if we're going to be faced with it right now. It's just something to have in mind as we kind of work through this process of developing our submarines. Let's see, we'll return now. So right now, you guys are here for the coding class too? Very nice.
I'll leave them here.
Very nice. So, what are some things that we do need to know about our submarine? How big it is. Yep, so we need our dimensions. And what else do we need to know? How fast, so we'll get our speed. Oh, if I can spell correctly. And how about where it's located? Let's see. So our new submarine will create.
So are you making two different types of submarines, or are you just gonna update?
Well, so that kind of goes, Brandon, right? I'm sorry, I'm so bad with names. I have to read them like a dozen times. That kind of has to go with his question, right? Where he was asking, well, do we want to have like a component that's like a vessel type? Because we could go down the road and we could have like a vessel type that the ship and the submarine both would contain. And then we could have like a submarine specific hierarchy, so a submarine specific struct that would then a specific submarine would contain. So we'd have like levels. It's so weird because I'm object-oriented programmer, goes into object-oriented programming. I want to say inherits, I want to say classes and all that, but that's technically not correct to say that. And so I'm kind of choking on my words. My thoughts are to have like a specific submarine super component is maybe a little bit premature optimization right now at this point. And so I think it would be worth, let's build this submarine and then maybe we'll talk about swapping the image out and swapping the statistics out, like the speed and the fire rate. And then maybe as you start developing, you go, actually, some more of these things are in common. It might make sense to refactor them out. So that's a great question. And I think for now, we'll just get a submarine on our screen and then see how we feel about that, all right? Okay, so we've got our dimensions, a speed, and a location. We can kind of define our speed, can't we? Okay, so entity. Okay, so sub speed. How fast do we want our sub to swim? That's the word that comes to mind. How fast do we want our sub to swim? Our ship goes at a speed of 5. Should this sub be faster or slower?
Yeah, slower than ramp up the speed on later levels.
See, and that's a great thought too. Is depending on the level, you can play with the speed. So yeah, good thought. And then we've got an image that we want to load. I don't have one actually in the game assets yet, so let's go out. Here I've actually shrunk these. I've shrunk, the original one was 256 and these are 128 wide. I kind of feel like the ship was kind of large on the screen. So eventually we'll get down to shrinking that. We can come over here. Do we want to make this one big or this size? Okay, so 128. And then I don't know exactly how tall I made it. Okay, I lost it. There we go. How tall is this submarine? Let's put this to pixels. 24.5, huh? Tell somebody who doesn't know how to do graphics probably designed that, didn't he? Okay. So I'll have a small submarine. And then we want to export this. Oh, of course, let's throw everything up there. Let's see, so our games and our submarine game and our assets. We'll create a new directory for this. We'll call it sub1. And then we'll name this 0.ping. Okay. So if we have our assets, we should have a sub1 and then a 0.ping. Let's see, asset loader, and we want to must load image. And it's going to be assets sub1 0.ping. And that, if I remember correctly, is returning an EB10 image. Yep, so we can just set the sprite, this image. All right. Return sub. So our new entity here has got some red squiggles. Red squiggles usually aren't good, right? What are red squiggles for?
Something that's like incorrect.
Incorrect. So let's look at our constructor function here. It takes an x and a y and a width and a height. So we don't really know what our x and a y is. Our width was the 128 and then our height was the 25. Let's see. This tells me that it still doesn't like what I put in there. I don't know if it's because of this. Yeah, that was it. Okay. I don't know why we're taking a pointer of a pointer, but for some reason this should be a pointer. There we go. Pointers are fun. Pointers are great. We're not really going to talk about them very much here. Know that they exist. Okay, so we've got a ship. We've got a submarine, but it's just at 0, 0. Do we want our submarine at 0, 0? Where's 0, 0 going to be? Yep, it's going to be in our top left. It's going to be just floating there in the air, right? So let's, before we go down that path, let's actually get our draw method hooked up. Options, and our options are going to be I have so many thoughts that are kind of in my head right now. It has to do with how we locate the center of our image and if we choose to draw and rotate about the center of our image. So if you think about it, so our submarine, I'm going to try to like biggest hands possible. So our submarine's here, and if we put the origin at the top left and then we rotate it horizontally, instead of like flipping it and it being in the same position, we're going to flip it and it's going to be completely on the other side. That makes sense? So we need to actually do a translation that will translate it to the center. So then if we ever have to translate it, it will translate it around the center. And I hope I do this correctly. So we need an s.width divided by 2 and our s.height divided by 2. And that's going to complain because we have the wrong types in our entity type. You make these kind of changes and you kind of always end up kicking the can down the road. Today we're going to have to fix the things that we didn't do last time. Remember how last time we were casting them all to float 32s because that's kind of what we had in the depth charge? Well, today our calls in our submarine they want float 64s, and so it makes sense today to just kind of rip the band-aid off and make it happen. So our ship speed up here is a float 32, and we'll make that a float 64. which means we'll need to make this one a float 64. Who can remember the difference between a float 32 and a float 64? It's basically just like the resolution, the maximum amount of the value that it can hold. They're still floating point numbers in this case. Okay, so our level is now not liking us. Okay, so this is where our depth charge now needs to be fixed. So we're going to fix a couple things. I don't know how that happened, but our gravity will be a float 64 as well. So here's where our fixes are going to come back and challenge us, because this draw field rect doesn't take a float 64, it takes a float 32. Weird, but we will go ahead and we'll convert them here. So this way we're only converting them one time instead of everywhere that we were going down the road to have to do that at. Okay, so we've got float 32s there, and we have our submarine and we're drawing. So now that we've gone and converted everything to float 64s that needed to be happen, now we can come back and revisit our draw. So if we think about it, we drew this in the center, and do we want our submarines to always face one direction, or do we want them to face both directions? So we want them to flip. So then we're going to have to store a value. So we'll have a horizontal flipped value. If that's the horizontal flipped. Okay, this is where I'm forgetting all these fun steps. So that's why we have libraries, right? So let's look at our draw for the library, and I actually do this here. So we have this minus float 64 width divided by 2. So that's right, we need to minus it because we're going to the center. And that's finding our center. And then so if we're horizontal flipped, then we change our scale. Again, I wish that I could walk through completely why all of this is the case. It has to do with a lot of matrix math, and it's translating all of the pixels inside of the image to do something different. I don't understand it well enough to completely explain it, and I think it's kind of beyond the scope to dig into it. But at least just know, if we set the scale on one axis to a negative, it will flip it about that axis. So now we've gone through the ability to flip it if need, and we're centering the image on our point. So now we have to locate it inside of our screen, and this is where we're going to do our X and our Y. And let's see, that should be everything for us. This animate component does a lot more things than our simple sprite drawing, and we don't need to do all of them. We just need to put it at its location. So now we can draw our sprite with our draw options. Okay. So inside of our level, we actually need to create a sub. how are we going to store our submarines? This is a slam dunk. We're looking at the answer right here. How are we going to store our submarines? In our struct, but we're going to store them in a special type. Remember what that type is? Our slice or an array. Or, you know, in Python world, it's kind of a list. I think like everything's lists in Python, so list comprehension, so how I hate those. I mean, they're powerful, but they're remembering how they work. So we've got submarines. So we're creating a new level. So right now, we could just say for, one of those good for loops, I is less than, let's index plus 1. Oh. Why in the world do I do an index plus 1 right there? This index is the game index, and if we're on the 0th level, and we go from 0 is less than 0, then we won't create any submarines. So at least we want to create one submarine. So level.submarines is append. Oh, what's that sign? I said is, so it's not equals, but it's let's see. Oh, we don't have a request torpedo function yet, do we? So right now, we will add that to our level struct as a method. Okay, now here's something kind of interesting. The request charge, it's just for the ship, and the game or the level knows where the ship is at. How are we going to know which submarine requested the torpedo? So we know where the right place to draw the torpedo is. Parameters. Yeah, so we can pass right into this call. So that means we're actually going to have to update our method on our submarine. So that it will take a submarine as a parameter when we set this up. But that way we can know which submarine is requesting the fire, so we know where to locate the torpedo. Because if we just like randomly guess, well, I think this torpedo fired, which in the end, that's probably going to be what happens. But okay, so we've got a submarine. And we got a level. Okay, should we run it and make sure we didn't break anything? We did a lot of programming just to try to get that figured out. Holy cow. So we didn't break anything, but we're not seeing our submarine yet. Anybody know why?
Is it written after or like in the wrong order? Why?
So we've added it to our game, but we haven't actually called its update or its draw methods yet. They'll get you every time. Okay. So sub.update, and then we should probably draw to all right, do you think we're going to see it now? I hope we do. There we go. So we've got a little submarine kind of centered right at 0, 0. Not very helpful, is it? So how do we want to place our submarine? Yeah, so logically, like if we were to just explain an algorithm of this is how the submarine is going to get its location, how do we think that would work? Like if you were to just stand up at the TV and say, I want a submarine here and here. What's the thought process that you're going through to do that? Did you randomly pick your locations? Did you strategically pick your locations?
I mean, you could randomly pick them within a range.
Yeah.
You don't want them
Yeah.
just anywhere on the screen, but you might want them within a certain depth that you do, and you don't want them off the screen.
Yeah, so like we look at our little handy dandy mouse cursor function. I can't see the first value because our screen, the window's kind of curved. But we're kind of looking for our Y, right? So this is at 140, and this is at like 320, and then 320 to 500 would kind of give us 3 sections of ocean that we could work with. Have you used any random functions in Python? A few times? Okay, so we're going to use a random function to place our submarine. So we need to find an X. See, actually we need to find a Y first. What were our height groups that we talked about? It was like 140 to 320, and then 320 to 500, and then 500 to 720, I think. Does that sound about right? So we have like a height group, and then we'll get to more random in a minute. But first, we're going to use math.rand, and if you use Go, there's actually, there's a new random package in Go, I think. There's like a random v2. I have to look it up because I haven't used the new, I haven't used random since the new package came out in this version. So we've got a math rand. Maybe it's not v2. Okay, so we'll just use this one still. What we're looking for is a method called rand n. Or int n, I suppose. This one right here. Int 63n returns, actually maybe we don't want an int 64, we just want an int n. Int n returns as an int, a non-negative pseudo-random number in the half-open interval of 0 to n. That's a bunch of mouthful gibberish, isn't it? Half-open intervals. Math stuff, isn't it? So we know that we don't want to place a ship below 140, and I would probably say maybe we actually don't want to, or above. Maybe we should go like 200 to 320. So we can do 200 as our lowest, rand.int n. What's the difference between 200 to 320? 120, yep. Math in front of people, that was great, because usually we all go, ugh. All right, and now we need to think about our X location. Do you think, should we start, we could say we could start at 0, we could start in the middle, or we could start at the far right. I say we just do, we don't have our width set yet, but we do know what it is. 12.5. Yeah. Why would we do 12.5? Oh yeah, this isn't in N, but we want that to be a float. 64. Okay, so should we check it out and just look and see what's going on now? Okay, so we've got this random submarine placed right there. And maybe my 12.5 was wrong because I did half of the height and not half of the width. So 64 is what we wanted. Okay, so we've got we have our submarine position. Should we throw just a couple more up on there just for fun? Yeah, I think so. I think we should draw more than just one. So we'll come to our main here, and we'll say we're going to start at, we'll start at level 5. And we'll see what happens now. Oh. Now it doesn't like me, huh? Actually, we will just tell the compiler that that's a float this time. Holy cow. We got some submarines in our game. But the problem is they're all on that top layer, right? How would we determine what layer we want those to be on? I would say, just for simplicity's sake, we could just do maybe that. And we could get a layer, and then have we talked about switch statements yet? Okay. Float 64. So we are going to see a switch statement. Okay, so if our layer is here, then we want our y to be this value.
Are switch statements just changing the data type?
A switch statement is a fancy if-else clause. So once I kind of work through this just a little bit, we'll talk about it in a little bit more depth. Okay, but those values are wrong, right? So basically, if we look at our 3 groups here, there's 200 to 320, 320 to 500, then 500 to 720. What we have going on here is we want to pick a random, like a random integer from 0 to 0, 1, or 2 is basically what's happening. In our switch statement, we say, okay, if our layer is this case, and in this case it's case 0, then you're in that first group. If you're case 1, then you're in the next group. So here we have to change our 200 to our 320. And, okay, more math on the spot. 320 to 500, that is 180. Is that right? And then our next one is going to start at 500. And that's going to be 220. So what's going on here is if our layer that's a random number gets picked as 0 or 1 or 2, it will put it in one of those horizontal slices that we talked about. So then if we did it correctly, hopefully we'll see ships, submarines. Now we have a problem because there's, what, 3 right there? But we'll have to maybe think about that. And so maybe it might be good, like, we're kind of hitting this point where we're assessing our logic and thinking, well, maybe it would be better to put this inside of the level just so that we know, oh, there's already a submarine there. We don't want to put a submarine there. But we can also kind of pick a random number for x value as well. I don't know what to call, layer kind of seems nice, but like what's a lane? We could call it a lane. And we could do another random. So just like up here, we did a int 3. 3. And then we could do a switch on our lane. And if we're in lane 0, then we could just say, let's move this up here real quick. Actually, I didn't even need to do that. I should do this. So for lane 0, then we'll just do that 64 again. And then if we're in the main lane, then we will go game, let's see. What do we call it over here? Screen height. Screen height. Oh, you're right, screen width. Screen width divided by 2 minus our ship's width divided by 2. That 128 is kind of a magical number right now. And then we could just do screen width minus that ship's width again. So now we're kind of randomly, we've got 3 lanes and we've got 3 layers that we can kind of randomly put our submarines into at this when they are created for the level. And so now we've got our ships that are, or I mean our ship and our submarines that are laid out. All right, what's our next step? Yeah.
So you're not doing a range for the width for the different lanes? You're just doing 3 different instead of ranges?
Yeah, my brain was just kind of like, I just want them either to start at the left, the center, or the right to make it a little bit easier because we're kind of short on time. But yeah, we could pick within that range like we did with the layer and then kind of position them within there as well. We could do that. All right, so now what do we need to do? Should we make our submarines move? Okay, so we have this horizontal flipped, right? They're all so far going one direction. So really all that we're doing for our basic logic, we're just moving it forward. I hope to eventually program in a crazy Ivan, and if you guys know what that is, crazy Ivan. Console, crazy. It's from a movie, but it's definitely not from your guys' era, so don't feel bad if you don't know what it is. But basically what we're going to do is we're going to take our X location and we are going to do the X and then we're going to we're going to add the sub speed to it on our update, and then our subs should move for us. Holy cow. And they're all just doing their own thing. But what's the problem? Yep. So now we need to do a couple things. I'm kind of thinking on the spot as we need to do this. So what we need to do, if the submarine gets too far to the right and it goes off, then we need to flip it. But we have a problem here because we've got our current X and we've got our sub speed. What if the sub has been flipped? We need to make sure that the sub speed is correct. So we're gonna, we'll put it down in code. So we'll call this a speed modifier. And we'll just say it's 1 right now. But if the sub horizontal flipped is true, then we want the speed modifier to be a -1.
So that it goes the other way?
Exactly. And then we can multiply our ship speed by our speed modifier. Let's see. reason, yeah, that's what I thought the problem was. So this is just telling us we need to have a float there. Yep, so if it's flipped, then we'll negative the speed and go back the other direction. But now what do we have to do if we get too far this way? So if s dot x plus s dot width divided by 2 is greater than screen width, what do we need to do? We need to flip it, and then we need to kind of reposition it. I don't know if we're going to worry about repositioning just yet. Then the other problem is, else if our s dot x minus s dot width divided by 2 is less than 0, I think this is going to work. I'm skeptical. We'll see what it does. Holy cow. No, like that's awesome. It's like dead silent in here. All right, so we've got our submarines that are driving. Now, right now our logic is super simple. It's just back and forth, back and forth, back and forth. And eventually we're going to want them to be able to fire as well, correct? And so inside of our update loop, we will need to figure out our logic to fire. So I think that's kind of where we'll pick up next week. Or, sorry, not next week because we're not going to be here next week, but next time. Next time we will pick up with firing torpedoes, and then we'll put the graphics on the depth charges, and then that will get us all primed to talk about two kind of complex things: collision detection and state machines. So does anybody have any questions from what we've covered so far today?
When you were doing your bound check on for like the right side,
Mm-hmm.
you did width divided by.
Yeah, so our point, so this is kind of a weird thing that definitely, yeah, I think is good. Our origin right now is in the center of the submarine. We changed that so that, I think you were looking at another computer, but if we were drawing right here and our origin was here and then we did a horizontal flip, it would flip it this way and then it would be wrong. And so what we did is we changed our origin to the center of the submarine, and then now we have to just make our math check that. So if you yeah, so if you see here, this translate in this game engine, it stacks. And so the first translation takes the drawing and shifts it half the width and half the height to put the center at 0, 0. And then the second translation moves it to where it belongs on the screen. So yeah, that's what we're doing there. I mean, it's a good catch because I think it's good to have it explained. For sure. All right, so there's that.
So the first translate is within its own space, and the second one is on the screen?
Again, 100%, I wish I could explain it perfectly, but it basically just stacks the translations. And so it does the translation, and then whatever happens after the translation is stacked. So like right here, we translate to the center of the image, and then if it's horizontally flipped, we do the scale to flip it, and then the next translation will locate it on the screen where it belongs. So it's just kind of a hierarchical step of transformations that it goes through while it's drawing the image. Yep. So I think that's all I have for tonight as far as like covering stuff, but I just wanted to jump over and introduce a topic because it's going to be kind of an interesting one. So I worked on a blog post the other day. I wanted to introduce maps. And I mean, maps are quite important because they're like slices, but they have indexes to the values so you can look them up. But as I got to thinking about it, unless you understand why maps are important, me walking through the syntax of a map doesn't really make much sense. Excuse me. So where we're going to be using maps specifically is when we get to transitioning between different animations. And so I just wanted to read this real quick. In a game, there's a main loop. With the case of EB Tension, there's an update portion and the draw portion. When we start animating our sprites, we'll be drawing a different image for each frame change. This frame change can be controlled by an animation component, say for every 1/6 of a second. We can change the frame to the next one and loop back. The catch is our game object can be in different states. Let's think about the game that I've introduced before. So I've been talking about the game that we're building here. Our player object is the ship above that can drop depth charges on submarines below. Let's think a minute for the states the ship can be in. So we have an idle state. That's where we're not running the controls. We have a forward state when we're driving forward. We can have a back state when we're driving backwards. And we can have a hit state if it gets hit by a torpedo. I've laid these out in such a way that the idle state is just kind of the default. If nothing's happening, you're in the default state. And then the forward state can override the idle state. So I'm picturing in my mind like the idle is just bobbing. And then when we go to have a forward state, we can like tilt the front end up like it's busting waves. And then when we go back, we could tilt the back end up like it's kind of breaking waves behind. But those states, you know, once you stop, you stop. But when you're hit with a torpedo, in games, usually they'll show like a flash animation, and that's kind of like you're in an invulnerable state. And the reason why that is because at 60 frames a second, if you get hit once and you didn't have an invulnerable state, you'd be dead because it would run 60 times. You'd get hit 60 times in 1 second and you would die. So that's why they do like an invulnerable state with the hit. And so we want like a flashing animation or just something different there. But the thing of it is, we don't want the backward, the forward, or the idle to be able to supersede the hit state. We want only one thing to supersede the hit state, and that is that it's run to completion, okay? So here is what I just said in a state diagram. So we have an idle state, a back state, a forward state, and a hit state. You can see that in our idle state, if we hit the forward, then we go to the forward state. And then when we're not hitting anything, we go to the stop. We call stop, and it puts us in the idle state. And same with move back. When we hit the back key, it calls move back and puts us in the back state. And then when we pick it up, it moves us to the idle state. And then any of these states can transition to the hit state. And then the only way that we get out of the hit state, like I said, is this animation complete gets called, and it puts us back into the idle state. So we're going to be using these states to manage our animations. And so now we've gone from like a discussion or an explanation to a picture. And if we drop down here, this is just introducing to maps, how to create them, how to assign values to them, and how to read them. But I just want to jump down here real quick. I've defined a type called ship state, and this ship state can be idle, forward, backward, or hit. And then just this string method will just print it out. It'll help for debugging. And then the ship input, which is the arrows on our diagram, is stop, which goes to idle, and then move forward, move backward, hit, and then hit complete. And then here is a map that's created. And this map is a type, the key is ship state, that can look up a map of ship inputs to ship states. And only if a current state responds to an input can we move to the next state. And then, so we see here like the ship hit, the only time we can respond is if it's a ship hit complete. And that's a mouthful. And then it will move to a ship idle. I know that's kind of a lot to go over and a lot to think about. I kind of show a little bit of this right here where we set up some simulated input that maps to this state set up here. And then we can run through the simulated input and it will output the state changes as it moves along. We're not going to be directly addressing this in the next class because, like I said, next time we'll do some torpedoes and put some graphics in and kind of do some fun things that way. But if you do have time to go over this one, this is probably going to be like the most, state machines are kind of hard to wrap your head around. So it'll kind of be the most crazy to start thinking about. So yeah, I think that's everything for today. Any questions?
For the states you had there, I guess it depends on what your animation was. Would you need to know whether you were going forward or backward as far as the animation for your hit? If your part of the ship is still being drawn, like if you're doing an explosion on it or something, or flat, you'd need to know the direction you were pointing, right? Or I guess it depends on your animation.
It depends on how complex you want your animations to be. Because you could have like a forward hit animation or a backward hit animation to kind of simplify state machines and some of our code for this. I just figured if you're moving forward and you get hit, we'll just show a hit animation just to kind of keep it a little bit cleaner. But yeah, we could have like a forward hit state and a backward hit state, and then they could respond to the animation complete. So we could do those things. Because ultimately what's going to happen is, let's look down here real quick. So we've got a map of states and the verbs that they respond to. And then we have a current state. And this current state is going to match the key that we use into the map of animations that we have. So then every time we do an update, we'll just say, oh, okay, here's my current state. Give me the animations for this state. And then update that animation and draw this animation. So yes, you could have multiple hit states and explosion states and things like that, like you're asking, but to kind of keep things a little bit easier to wrap our heads around, we won't do that this time.
Cool.
All right, any other questions? Okay. I drew some explosions right here. For the non-graphics guy, you know, it's okay. All right, well, I will stop our video here